All right, lesson 5 for our statistics unit here for 9:30. So far we've been talking about a bunch of different data displays, dot plots, box plots, histograms, fun stuff like that. Today we're going to change gears a little bit and we're going to talk about these things called two-way tables and how you can use these two-way tables to find relative frequencies, which are it's just another word for kind of some probabilities or ratios that we could find when we organize our data in this special way called a two-way table. So we'll be able to figure out how we complete these two-way tables, fill in some empty spots, and then also how you can calculate and compare some things that we call joint relative frequencies, and I'll show you how to do that as well. So this is what a two-way table looks like. Now it's called a two-way table because generally when we make a table, you know, we kind of usually just put totals down at the bottom or off on the right, but not both ways, right? Usually you have your columns and your rows and you add things up down at the bottom, or you would add things going across, but in a two-way table you do both. So what we see here is the numbers in the middle. So this table is showing the comparing some people who bought SUVs compared to some people who bought sports cars. So if you kind of just take a look at these in different ways, so our top row here, these are all of the males that were in this study or this survey. So anyone who is a male, there were 21 of those males that bought SUVs, and there were 39 males that bought sports cars. So you can see that they added them up going across, and the total number of males in this study was 60, right? They talked to 60 different men. All right. So that's the males, but then you could look down at the bottom and here's the females. 135 girls bought SUVs, 45 girls bought sports cars for a total of 180 girls. So these marginal frequencies, these totals are just adding up those rows. But in a two-way table, you don't necessarily only talk about rows, but you talk about columns as well. So we say, okay, well here in this first column, these are all the people who just bought SUVs. So 21 males, 135 females. That means 156 total people bought SUVs. You could look at this column then and say the number of people who bought sports cars, 39 men, 45 women, for a total of 84 people who bought sports cars. So these marginal frequencies are just the totals of either the rows or the totals of the columns, right? And then you could add all of those up to get your grand total of there were 240 people in this study. So you could either add the 60 and the 180 to get that 240, right? Add down, or you could add across. 156 plus 84 gives you 240, or honestly you could just add up the numbers in the middle, these joint frequencies, right? These are the actual numbers of people. If you added all 4 of those numbers up, you'd get 240. So it kind of just breaks down the numbers a little bit differently so you can compare them both, and then runs totals either going across or going down. So that's what a two-way table looks like. Now the question is, how do we use these? All right, so sometimes we don't have all of the data, but we can kind of use what we have to fill in the blanks. So remember again, these marginal frequencies, so this guy down here, these are the totals going across the the rows. These guys are the totals coming down the columns, and then this would be the grand total over here in the corner. So I would guess you guys would be able to fill in those missing spots based off of what we know already. So pause your video and see if you can't fill in those 3 missing spots. All right, so what I look for is I see, all right, so I have this grand total down here of 47. I know that this is all the students who eat breakfast. There are 12 of those students that were in the age range of 14 to 17. And there are 47 total who eat breakfast. So this must be 35 right here, right? 35 plus 12 equals 47. Maybe you went across and said, okay, well, there's 54 total students ages 10 to 13. So that would mean that what number plus 19 gives you 54? Again, 35 plus 19 gives you 54. So you could do either one of those to get 35 in that top left box for our number of students 10 to 13 who eat breakfast. All right, then we need to fill in this middle box here, right? So here again, I would say, all right, here's 43 total students who skip breakfast. I know that 19 of them are ages 10 to 13. So what does this number have to be to add up to 43? Well, let's see, that would probably have to be 24, right? 19 plus 24, 30, 43. Or you could say, go across this way, right? I know that I have to have 36 total students who are aged 14 to 17. I know that 12 of them eat breakfast, so 12 plus how many has to equal 36? 12 plus 24 equals 36. So you got 24. You could do it either way to fill in that middle box there. And then finally we have our grand total, so we could add these two, come down. 54 plus 36 gives me 80, 90. Or you could add these two across. 47 plus 43, 80, 90 that way as well. So 35, 24, and 90 would be the numbers we had to fill in that box. Hopefully you start to get the habit of that. You kind of look for one where you're only missing one number, either in a row or a column, and then you work your way out from there, kind of like Sudoku for anybody who likes to play that game. I love it. All right, so here I have that completed table with the numbers we just figured out. So after you complete the table, then you have to start analyzing it, right? How can we use this information? So one way to use the information is to ask for ratios, right? So letter A here says, what is the ratio of students that are 10 to 13? So I just want to know, in this whole study, what's the ratio of students that are 10 to 13 to the total number of students? So in this one, all I'm looking for is that marginal frequency of 10 to 13. So there are 54 total students who are 10 to 13, and there are 90 total students, right? So my ratio would be 54 over 90. Now remember, whenever you are doing a fraction, you always want to reduce it. Now what jumps out at me right away is that I could divide both of these by 9. So that would give me 6 over 10. Ooh, that's not enough. Divide again. So I would get 3 over 5. So my ratio of students that are aged 10 to 13 in this study is 3/5. So 3/5 of the students are aged 10 to 13. You could also use that ratio then to figure out, oh, well, how much are the students aged 14 to 17? That would be 2/5, right? What's left? So there are a little bit more students that are aged 10 to 13 than 14 to 17 in this study, and that kind of helps you gauge, the numbers that you're seeing in that table. So it helps you analyze it a little bit. All right, part B then says, what is the ratio of students that eat breakfast? So again, using that marginal frequency, I'm just comparing total number of students that eat breakfast compared to the total number of students in the study. So here I am looking at 47 students eat breakfast in this study, and there are 90 students total. So my ratio here would be 47 out of 90. Again, we would try to reduce that, although I believe 47 maybe cannot be reduced. So I think that this one is just 47 over 90, and that's okay, right? Sometimes that's what we need, and you can kind of use that to compare. Let's see, 47 to 43. Yeah, that's pretty evenly split between students who eat breakfast and those who don't eat breakfast. Interesting. Okay. All right, and then the last ratio is one that's a little bit more specific, and this helps us kind of lead our way into this joint relative frequency idea, because now we're going to break into these these joint frequencies in the middle, because it says, what is the ratio of students that are 14 to 17 that skip breakfast? So what is the ratio of students 14 to 17 that skip breakfast? So this time, I'm not looking at the entire table. I'm just looking at the students who are 14 to 17. So I narrow down my table to only that row. I'm just focusing on these students who are aged 14 to 17. Maybe that's my target market. Maybe those are the students who I see the most often, and I want to find out, for whatever reason, we want to kind of narrow down our data to only that row instead of everyone. So what's the ratio of this row, 14 to 17, that skip breakfast? So in this one here, my number who skip breakfast is 24, but the total number that I'm looking at in this is only the total number of students aged 14 to 17. So I have 24 out of 36. And again, we're going to reduce whenever we can. So here it looks like I could divide both of those by 12. So I reduce this and I get 2/3. 2/3 of our 14 to 17-year-olds skip breakfast. Oof, that seems like a lot, right? Do you see how those ratios start helping us analyze the data? Otherwise, all we see is this big bunch of numbers, and it doesn't really tell us a lot. So, using those, what we call joint frequencies. So you gotta be careful on how you read these, right? If it just says ratio of students that are 10 to 13, right? You're judging those marginal frequencies out of the total. If it gives you more, if it has two different categories, then it's telling you narrow down, right? Narrow down that table, the ratio just of students who are 14 to 17 that skip breakfast. So you really have to read carefully, and that's the trickiest part about two-way tables. All right, so making ratios is one way to analyze data, but really a more common way with two-way tables is to find probabilities, right? Probabilities show up as fractions like those ratios, but they also show up as percents, right? Percents a lot, even more than decimals. So usually your probability is either going to be a fraction or a percent. And in these ones, we're going to make sure that we always do percents, and we're going to make sure, just for this sake, we're going to round to the nearest whole percent. Okay, so I'll show you what that means, but that's going to be for all of our problems today. We're going to round to the nearest whole percent. They'll usually have to tell you that, so be careful. Sometimes they want tenth, whatever, but we'll go whole percent here. So here it says, what is the probability that a randomly selected student will be aged 10 to 13 and skip breakfast? So what's the probability out of all of the students, that they will be 10 to 13 and skip breakfast? So if I look at that, I got to look at my joint frequencies here down in the middle. They got to be 10 to 13 and they have to skip breakfast. So it looks like I am going to be using this number right here. There are 19 students who are aged 10 to 13 and skip breakfast. And I want that, what is the probability, if I pick any one of these 90 students, that they will be 10 to 13 and skip breakfast? So my ratio, my fraction for my probability would be 19 out of 90. Now, if I want the percent, I need to actually type into my calculator. So I'm going to switch over to my calculator here. And I'm going to type in 19 divided by 90. And I get 0.21111111111, right? Oops, there's my voice. Sorry about that. 0.2111 dot 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 dot. So if I want to round that to the nearest whole percent, remember, to change a percent or a decimal into a percent, I need to move my decimal 2 places, right? So it'd be 21 and 0.111, so that would just make it, round it to 21%, right? The 1 says to stay at 21. It would be like 21.111 da 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 da. So when I look at that, the 1 tells it to stay at 21%. Okay, so again, this one said 10 to 13 and skip breakfast. So I was looking for just that 1 out of the total. All right, here's another way to look at probability. Again, here, we're going to round to the nearest whole percent. This time it says, what is the probability that a randomly selected student will be 14 to 17 given that they eat breakfast? Okay, now this one says, given that they eat breakfast. That means that I am narrowing down my whole table. I'm not going to use the whole thing. I'm going to narrow it down to only this section that says that they eat breakfast. I know that they eat breakfast already, so ignore everything else and only focus on the eating breakfast students. So I want to know, what is the probability that these students will be 14 to 17? So the number who are 14 to 17 out of the total number that eat breakfast. So my fraction would be 12 over 47. But here on this one, the probability, I'm going to change this into a percent. So again, 12 over 47. So I'm going to switch on over to my calculator, type in 12 divided by 47. and I get 0.2553, etc. So I type in 0, or write down 2553, ... right? Change it to a percent. I have to move my decimal 2 places, so this would really be 25.53, ... Ooh, that 25 looks at that 0.5 and tells me to round up to 26%. 26% of my eating breakfast students are my ages 14 to 17. So that means that more of my eating breakfast students are coming from that 10 to 13 age range. All right, so hopefully you get the idea. Whenever it says that given, right, that's when you're narrowing down your table. All right, we got one more here. This one says, what is the probability that a randomly selected student will eat breakfast given that they are 10 to 13? Why don't you pause your videos and see if you can figure this one out. All right, so again here, finding probability, we are given that they are 10 to 13, so we already know that. So we're narrowing down our table to only the ones that are 10 to 13 years old. So we're only focusing on this row right here, right? I don't care about the 14 to 17-year-olds. I already know my student is 10 to 13. I just want to know what's the probability that they will be eating breakfast. So that fraction would be 35 out of 54. And then I'm going to type that into my calculator, 35 divided by 54, and I get 0.648148. 0.64814, ... right? And then we're going to make sure we round it to the nearest whole percent. So I move my decimal 2 places. I get 64.814, ... This 4 for my 64% looks at the 0.8 there, and that tells it to round up to 65%. So 65% of my students who are age 10 to 13 are eating breakfast. More eat breakfast than don't eat breakfast. You can kind of use that to kind of analyze the data a little bit more. All right, so hopefully that gave you a pretty good idea. So you're using those marginal frequencies, those are the totals at the end of the rows or columns to help fill in any missing spots if you need to, right? And then you're either finding ratios or probabilities to help you analyze the data in that table. And just really be careful of the wording, right? A lot of times when they talk about two different things, many times you're gonna be narrowing your table down, but unless they're asking you for, these two things are both together out of the total. So you really have to read carefully. If you see that word given though, given that they are a boy, given that they eat breakfast, that is a for sure sign that you are going to be narrowing your table down to a specific row or column. So that's a really key indicator. Sometimes it doesn't necessarily have that word, but that is definitely a good word to help you know that you're going to narrow down the table. All right, good luck with your two-way tables.